So, friends, good morning and welcome to this lecture series of geomorphology. Today, we will discuss about seismic geomorphology. So, if you remember or summarize up to the last class that we have already covered these geomorphological processes that are acting on the surface at the present time. And mostly that is the aeolian process, fluvial process, glacial process and coastal processes and weathering, erosion, mass wasting and tectonic geomorphology. That means all aspects of geomorphology that we have covered, and the maximum the geomorphic processes that we have discussed, they were working on the surface only. So, they are modifying 24/7 to the surface and making this earth surface peneplane. So, today we are going to discuss something about geomorphology which was the past. That means, the geomorphic processes which are acting in the past to make this landscape peneplane, and now we are recording through our instruments and these techniques like seismic, and through this seismic profile we are studying the geomorphic processes that were acting in the past. So, what is its utility? First, the use of this seismic geomorphology is to understand the paleogeographic conditions and to understand the paleo or the ancient depositional environment, the ancient geomorphic processes that were acting in millions of years back or in the thousands or lakhs of years back, and those signature of these geomorphic processes, they are recorded within the rock and being detected with our instrument like the seismic technique. So, moving forward, if we say what does it mean? What is seismic geomorphology? If you see here, there are three figures. The photographs, they are taken from this Google, and these three that indicates that the seismic signatures of particular geomorphic and tectonic processes that were acting in the past, and they are preserved in the rock record. It is looking like a river. That means, a river which is they are moving in this way, and these are the point bars. If you remember, they are fluvial geomorphology, these are the point bars, and this point bar migrate, that is a separate part of story. But if you see here, it is looking like the river and they are the point bar migration. Similarly, if you see, these are the migration of the point bars. So, that means, now a geologist who has experience, by looking this image, he or she can guess, yes, it is a river or it is a fluvial process, a meandering river, and this meandering river, that is here these point bars are abandoned, and now we can correlate it the fluvial geomorphic processes. Now, if you question arises, if this fluvial process is there, when it was working and how it is preserved. Now, you see, this is a slice, simply it is a slice from a 3D surface or the 3D cube, and within a particular time scale, in a particular time slice, we have make it available in a 2D form. And now, you see, that means, within a 3D sequence or within a subsurface sequence, this part, this particular geomorphic process or particular river process as the meanders, it was there. Now, we have removed the upper part. Now, we are able to look what was happening in the geological past, because once we have removed upper part, that means, we have reduced the time, we have deducted some geological time, and we have moved back in geological time to a certain time scale, and a certain point of the geological time we found that this river process was working and it is a meandering river. Now, here you see, this is a 2D seismic profile, and the seismic profile, if you see here, these are these depositional systems, they are these onlap, uplap, whatever downlap, that you know it is probably you know it from your sequence stratigraphy. So, now you see how it happens. It happens, it is an interaction between a pluvial and a marine process, the sedimentation process. So, that means if we are able to interpret these things, so that means we are able to interpret the past geomorphological processes acting at that particular place. So, that means here suppose this is the, for example, suppose this is the surface level, and at this level we are getting this onlap, downlap, whatever these sequences that are, that is the sequence stratigraphic signatures are here. That means we have to see it, we have to move up to this much depth. So, this much depth means it is corresponding some geological time. So, that means if we are removing this much geological time from that place, we are able to see it on the surface. So, that means those geomorphic processes which were working in a particular geological time, that process or the product has been there fossilized there, and through the seismic process we do not know the subsurface. So, for studying the subsurface we are going for indirect method of study like the seismic, because we do not know the surface of what, we cannot see it directly what was happening in the subsurface process. And here once we are removing this much geological time and this much rock, we are reaching here in a sequence where the sequence boundary are there, something whatever the sequence stratigraphic nomenclature is there, that where we are getting it. So, that means sequence, that means here if you see the marine process and a pluvial process, they are interacting here, and with time if you see this marine earlier for example it was here, if you project it back it will be somewhere here. So, if you are again if you are changing this sea level, it again this depositional process progradation will be there and it is coming here. So, that means with time how the paleogeography changes, with time how the sea level fluctuation was there, with time how the depositional sequence or the pluvial processes they were migrating to seaward or to landward. So, these are the geomorphology, that means part of geomorphology we have discussed. So, that means in this seismic stratigraphy or the seismic geomorphology, we are interpreting the geomorphic processes and their product from seismic profile. So, seismic profile may be of 2D or may be of 3D. For example, here is a 3D seismic profile, it is given 3D seismic cube or seismic block is there. If you see here, particularly as a geologist or experience, you have experienced some geological structure, you can see here it is coming and here. That means we are expecting there should be a fault here. So, here we are getting, and this fault is not exposed, may or may not exposed. So, now that we have information about the subsurface structure, we have information about the subsurface processes, we have information about this time processes. So, that means in a particular geological time what was happening in this subsurface, that means then surface, nowadays it is subsurface, then it is surface, because geomorphic processes they are near surface processes or surface processes, except weathering and erosion that is that can affect to certain depth, but all other geomorphic processes they are the superficial processes. So, that means these are the geomorphology of ancient past. So, that means these were once upon a geological past, these were the surface processes, within that surface and with time they are buried, and due to burial now they are in the subsurface. Through the seismic profile we are able to interpret what was the geomorphic processes and their products they were in the geological past. So, this is the main aim of seismic geomorphology. So, by definition if we move, seismic geomorphology may be defined as the application of analytical techniques pertaining to the study of landforms and to the analysis of ancient buried geomorphic surfaces as managed by 3D seismic data. So, it is may be 3D or maybe it is 2D. So, here it is a 3D profile and here it is a 2D profile. So, that means it is the study of ancient buried geomorphic surfaces. So, geomorphic surface nowadays, for example, whatever is happening nowadays, for example, take the example of the east coast, we have interaction of marine and we have interaction of rivers. So, these are the surface processes that are happening in front of us. and surface. Now, suppose for example, there is rise of sea level or there is coastal encroachment of marine transgression. So, that means nowadays the surface which are happening in front of us, the surfacial process, that will be buried by sedimentation. And in geological future, if you want to study what was happening in this time, that means the present time. So, we have to go for either we have to go for trenching, pitting or drilling, or indirect method is seismic or any other geophysical methods. So, that means these past geomorphic processes, past geomorphic surfaces, how we can unravel through seismic profile, how we can interpret, that is the main aim of this seismic geomorphology. So, aim of this study is reconstruction of a paleogeography, then analysis of a paleo environment of a deposition and surfacial processes. That we know, first is this reconstruction of paleogeography, because land and sea distribution. This profile that we discussed in the last profile, how this sea level was moving, how this coast was moving to and fro. Similarly, how this fault was acting in the geological past, how they are affecting the sediment overlying sediment cover. So, that means it is reconstruction of a paleogeography, where the river, either this river process which are acting in geological past, the same river process acting at present or in recent geological past. So, that either it is buried or it is occupied by another process, the marine process or aeolian process. So, that means different geological processes, they can be clubbed or they can be seen through a seismic profile in a particular geographic location. Analysis of paleo environment of deposition and surfacial process. Paleo environment of deposition and surface, that means it is the geomorphology and sedimentology. And you see, these depositional processes, they are the product and the geomorphic process. See, river process, it is geomorphic process, but deposition is either a floodplain deposit or it is a natural levee deposit or it is a point bar deposit. So, they are the product. Sedimentology is the product, geomorphology is the process. So, the geomorphic processes that led to the depositional process, the deposition of materials, deposition of sediments. So, geomorphology is the process and sedimentology is the product. So, that means paleogeomorphological processes that can be studied through seismic geomorphology. Now, how to do it? If you see here, this is done by reflection, seismic map and sections. So, reflection, seismic map and sections, so that means there is principle. In seismics, we go for seismic data acquisition and then seismic data processing. So, acquisition, if you see this figure, it is just a fundamental diagram it is given. So, here we have a seismic source. From the source, we are sending these waves and the waves they are moving back at different geological interface. Suppose for example, here one interface is another interface, it is third interface. So, from the different geological interface, so the interface, that means it may be lithological boundary, it may be any, that means it may be water table, it may be any interface which is different in character than the first. So, that means that will reflect these from this interface, this wave will reflect back, and this reflected back wave that will be recorded through geophones. Now, we have to interpret it, we have to process it, and after processing we have to interpret it. So, these are the processed data, these are the processed data, these are the processed data. So, this processed data has to be interpreted through geological knowledge. Okay. Now, you see, once it is, now you see here from this interface it is reflecting back, from this interface it is reflecting back, from this interface it is reflecting back. That means, we are getting here one interface, second interface, third interface. So, either it is a lithological boundary or it is a density contrast of for anything. So, these are these main surfaces from which this reflection will come back and will be recorded here. Now, these from this data, if you see here this geologist, experienced geologist, what you can interpret here. So, this is representing a non-conformity surface, isn't it? Similarly, here these are the sequence boundaries, this seismic stratigraph or sequence stratigraphy if you know it. So, these are the sequence boundary. Similarly, here these are these faults, from here this seismic data is interpreted, these are the faults within the basin. So, that means I want to say unconformity surface, depositional boundaries, structures, all those things, all those geomorphological elements that can be detected and interpreted from this seismic profile, and then can be correlated with the geomorphic processes we are acting in the geological past. So, this seismic reflection, it reveals details of internal stratigraphic geometry. We have internal stratigraphic geometry, either it is a unconformable strata, conformable strata, either onlap, uplap, downlap, termination, whatever may be. So, we can interpret here. So, why I am talking about this? This onlap, uplap, downlap, unconformity, these are this process, these are the product, but the process is the geomorphic process. For example, onlap, uplap, downlap, they are the geomorphic process involved. It is the interaction of a marine and fluvial system, sediment progression, sediment distribution system. Similarly, here this unconformity, unconformity is the product of erosion or non-deposition. So, that means here also geomorphology involved, here geomorphological process involved, here geomorphological process involved. So, everywhere we want to pick out the geomorphic processes that are involved in this geomorphology, in this seismic profile, is not it? So, it reveals the detailed internal stratigraphic geometry, and that can be interpreted in terms of depositional environment and paleogeography and sequence stratigraphy. So, these are the informations we can retrieve from a seismic profile. So, we have the information about depositional system, and we know the depositional systems or depositional environment, they are governed by the geomorphic processes. Deposition, where deposition will take place? There will be aeolian processes, aeolian geomorphology, it leads to deposition. There will be fluvial geomorphology, that leads to deposition. There are glacial geomorphology, leads to deposition. Coastal and marine process leads to deposition. So, that means the depositional environment, once we say, that means we are bracketing some geomorphology, we are involving some geomorphic processes with that. Similarly, paleogeography, paleogeography means it is a interaction of the geomorphic process. Sequence stratigraphy, interaction of geomorphic process. Internal stratigraphic geometry, that means it is a product of geomorphic process, is not it? So, everywhere geomorphology is attached with it. The sequence stratigraphy was started at seismic stratigraphy by the prominent oil companies like Exxon and Shell. By seismic method, a lot about basin geometry, basin fill composition and style can be derived, and if having good quality of data and proper interpretation. This is also important. This seismic geomorphology, where it comes? It comes from the seismic profile, and first it started with sequence stratigraphy and then seismic stratigraphy. From the stratigraphic record, we are unraveling, we are retrieving the geomorphic processes involvement. And this seismic method, it says a lot about the basin geometry, how the basin will look like. If you see here this basin geometry, that means now you see here how this basin, either earlier there are two basins, now it is representing one basin here, but if you remove this much geological time scale, you remove this much sediment, then finally we are coming with isolated basin, one here, one basin here, one basin here. So, that basin geometry in geological past, either that is evolved through one basin to multi basins, or multi basin is coalescence, it is forming, now representing it is one basin. So, it is this reveals the basin geometry. Then structure. Structure means, if you see here we have faults, we have folds, we have unconformities. So, like these are the structures that can be that can be retrieved, or information about the structure can be retrieved. Then lithology. Lithology, here different lithology, either we are dealing with sandstone, limestone, shale, or whatever may be there, the lithology is there, that can be retrieved. And style of deposition, similarly we have onlap, uplap, truncations, so downlap, whatever may be, or there is a unconformity bound sequence. So, that means how the style of deposition was there, that means everywhere we are involving geomorphic processes. So, that means seismic phases or the seismic stratigraphy or the seismic sequence this is seismic profile that will reveal the information about the basin geometry, about the structure, about the lithology and about the style of deposition, and which in turn are related to geomorphic processes involved in their formation in geological past. So, like seismic geomorphology, we have another geomorphology that is called GPR geomorphology. That means GPR stands for ground penetrating radar. It is equivalent to seismic. However, if you see this profile is looking like seismic profile, but actually it is a geomorphic, it is a GPR profile. So, here some geomorphological information, some geomorphic information in the recent geological past, that means it is depth wise its restriction is there up to 45 meter or 40 meter or 50 meters or so. So, that means at the shallow subsurface level, what was the geomorphic processes was involved in their formation in the recent geological past, that we can unravel. For example, if you see this photograph from GPR profile, as a learned or as a experienced geologist, you can say here you can restrict yourself, that it is looking like somewhat a channel. So, that means now you see at the surface level this much we do not have any information, only parallel reflections are there, but once we are moving to this much depth, we are getting a patch which is looking like a channel which is buried. So, that means it is a paleochannel, and this is a GPR, and this was taken from Patel et al, which is in press, and this is Patel is standing. So, that means this information which we are retrieving from a GPR profile, it is equivalent to seismic profile, and the difference is that the depth and there is this process. Here we are using EM wave, and in the seismic profile we are using shock wave, or that is the seismic waves. So, the principle is different, but this aim is same, and at the seismics we can go up to kilometers, up to kilometer 4, 5, 10 kilometers, but here we are restricting ourselves within few meters, even if less than 100 meters. So, in a shallow level means very recent geomorphic processes. So, at shallow level what was happening in a very recent geomorphic processes that can be retrieved through GPR profile, and at the deeper level in kilometers depth what was happening, what are the geomorphic processes was there that we can retrieve from the seismic profile. Here is another photograph, and it is also from the same. Here you see there are faults, shallow subsurface faults, and here shallow subsurface faults, and in this photograph you can see in a seismic, this is the also a GPR profile, you can say here layer 1 it is silty sand, it is layer 1 here, it is interpreted as silty sand, layer 2 it is weathered rock, and layer 3 moderately weathered rock. That means even if the intensity of weathering, the degree of weathering that can be detected through. So, weathering which is a geomorphic process. So, that means either it is a seismic profile or it may be a GPR profile, through which we are unraveling the geomorphic processes acting in recent or in ancient geological past, that is clubbed or that is fossilized there, and we are able to extract it, interpret it from the seismic profiles and the GPR profiles. Seismic phases are the interpretation from stratigraphic geometry. These are called the seismic phases, and there is stratigraphic arrangement. If you see how the sequence boundary is there, and from there will be onlap, these are the downlaps. So, that means there will be landslide, and there will be any tsunami sequence, tsunami deposits. So, there is a depositional sequence. So, all these informations can be retrieved from this type of profiles. So, here there are certain patterns which is defined by this pattern of reflection of seismic profile. You see there is parallel pattern, then semi parallel, then contoured or mound shaped, oblique, then again it is oblique, then chaotic, then contoured, then mound shaped. So, that means these are this, if you see here, this is parallel pattern. So, there are reflections which are parallel. Similarly, here reflection that is not exactly parallel, that is called semi parallel. Here it is contoured and mound shaped. Here your mound shaped are there, contour and mound, you can draw contours at different levels. Then oblique, if you see here it is oblique, it is moving like this, it is oblique typing. Then again similarly it is oblique like this, then it is chaotic, there is no any arrangement, there is no any particular site of reflections, there is chaotic. Then again it is contoured to mount shaped, it depends, that means these are these ideal reflection patterns through which the depositional environment can be retrieved, and those depositional environment can be correlated well with the geomorphic processing environment. For example, here we have parallel reflections, that can be interpreted as pelagic and hemipelagic, that means it is a deep sea geomorphic process, is not it. Then it is debris flow, hyper concentrated density flow and turbidite, it is also at the continental slopes. Then debris flow, hyper concentrated density flow, here it is landslide or mud flow landslides that we have discussed in mass wasting processes. Then lower slope slumps and large lithified collapse block, it is landslides, it is submarine landslides. Then it is reverted upper slope, then platform interior, then it is karstified platform top. So, that means here this depositional environment, or obliquely we can say it is a geomorphic processes involved. Okay. So, that can be interpreted through this type of reflection, and these are the ideal reflections, not necessarily in a particular area, in a particular seismic profile, all types of information, all type of reflection pattern we can get. Seismic section gives reflection with time, not depth, mind it here. Whatever this 2D seismic profile we are getting, or whatever is here, it is giving this axis, it giving time, not depth, but from the time to depth we have to calculate, and this is basically done by the geophysicist or the seismologist. So, seismic velocity increases with depth due to increase in density and decreases in porosity, because once we are going down, so due to more and more overburden pressure, the porosity decreases. Similarly, the density increases, because once porosity decreases, that means the pore space is occupied by grains and the density increases. So, that means with increasing density the velocity increases, and an empirical relation that is called first equation, it is equation described the seismic velocity with depth and the edge of the rock. So, here velocity equal to 46.5 ZT to the power 1 by 6. So, V is the seismic velocity, Z is the depth of burial and T is the geological time in years. So, this is a first equation, but not necessarily this equation is qualified to be applied in every geological sequence, depending upon the terrain, depending upon the rate of sedimentation, depending upon this proximity to plate boundary, or at the basin interior, or at the basin at the periphery. So, that means though this equation, it is empirical equation is there, empirical relations it builds between the time and velocity in geological time, but it is not applicable everywhere. So, the seismic method was started in 1970 with the assumption that seismic amplitude reflections approximate geological timelines was fundamental to develop the seismic stratigraphy or the seismic geomorphology. So, here if you see, suppose we are sending the seismic wave down. So, now you see here this reflection, this is reflection, this is reflection. Similarly, another reflection here, that means it is changing in amplitude. So, if you are getting this the wave propagation to depth. So, there are certain points where amplitude is very high or very low. So, this low and high amplitudes, these are this product or these are the function of the change in formation properties. The formation properties may be due to density change, may be due to lithological change, may be due to presence of fluid within that. So, these changes can be retrieved from here by this amplitude changes, and this can be interpreted to different litho units, and these litho units they are related to geomorphic processes. So, discrete seismic reflection package such as depositional sequence, discontinuities like downlap, onlap, truncations or toplap, it is signify the paleogeographic conditions in a definite geological time scale. This in sequence yield the paleogeomorphological condition of the region. So, that means those depositional sequence, they are indirectly or directly they are revealing or they are pointing towards the involvement of the geomorphic process in a particular geographical area and geological time scale. Okay. So, these 2D based interpretations were then mapped and spatial distribution of the depositional systems with associated lithological predictions subsequently interpreted. And if you finish here, these are the interpreted map and these are the seismic blocks, this is 3D seismic sequence. From the 3D seismic sequence, they are the interpreted. Now, if you see the interpretations, here we have some inclined strata and now you are getting a parallel strata here. So, that means we can say it is a unconformity surface, is not it. So, this type of interpretations comes out and that now suppose we are involving here, that is a unconformity surface here, that means they are exposed to the surface, there are erosional processes. So, these erosional processes involved in this interpretation from this seismic profile. In recent days in seismic geomorphology, the extraction of the geomorphic insights using predominantly 3-dimensional seismic data is rapidly evolving discipline that facilitate the study of subsurface using plan view and images. So, here there are 3D seismic sequences. From the 3D seismic we can interpret how this, depending upon this reflection pattern, which type of geomorphological processes, what type of the depositional process is involved, we can interpret through it. A variety of computer based analytical techniques is employed to image and visualize depositional elements and other geologically significant features. The data can be cut horizontally, which is and vertically, which is representing the process and time, because horizontally that means the geological processes, the geomorphological processes side by side, and vertically that means geological processes with time. So, the vertical line it is indicating the time sequence, the horizontal line it is indicating the lateral or the longitudinal change in the geomorphic processes as well as the depositional systems. So, that means with time whatever the changes are there, similarly laterally or with space what are the changes is there. So, both time and space, with time and space how the geomorphological processes evolved and changed, that can be retrieved, that can be correlated, that can be interpreted from the seismic data. So, this provides a map view over geological time from which depositional element and system could be interpreted. So, these are this sequence of how this things works. We have seismic data input, then seismic data enhancement, then refinement of interpretation, then seismic attributes, then it is seismic phases analysis, then it is fractured index map. So, starting from the input data and how we are coming to interpretation, that is the process. So, I think we should stop here and we will meet in the next class. Thank you.